So before continuing, basically I skip what it's just some cable management. So I just put that out of the way so you can see. So I'll get the connection to the heating element, the connection to the relay control for the bed. The bed is linked here, not fun here because this is high voltage. So yeah, it's insulated, but I really don't like that. But anyway, so here everything is linked except the cable, which is going to be like that or maybe under, I don't know how. It's just for some kind of visibility. We got fan 1, we got fan 0, fan 2, which are for the heating and for the blower on the side of the block heating. We've got the X stepper motor, connection to the X stepper motor, connection to the extruder, connection to the Z left, which settle down for the extruder 1, so it should be fine. We've got our T-bed, we've got our T0, we've got our probe, we've got the E1 stop, so this is for the Z left. We've got ground, we've got plus 5 volts, so this is for the end stop, which are optical detection. The E0, so the extruder sense, this is for the filament running, and we've got the X stop. The two left here and here are for the Y and the Z right. So Y here for the stepper motor, Z right stepper motor here, the end stop here. So technically I should have a connection here for under there. There's the Z right, but it's not wired like that on the Chiron. You got here from this side, you've got a cable with all what you need directly here. So I need to confirm, like, first I have enough cable to wire there, because the stop are not on the same direction. So it was like that, and the stop were more closer to the edge than there. So I may have to do a new cable. We have to confirm that, and we have to remove the GST PH. I think it's a 8 pin in order to plug there, and of course put back the PSU and wire the rest and put back on the main unit. before continuing, we need to talk about the railings and how to install them. So I found this on Thingiverse. This is something to help you to center railings on 40 by 20 extruded aluminum rail. Here what it looks like, and now I know this will not move. And the thing is, I bought 550 millimeters long railings because I know the 600 won't fit, and you need to cut or print new corners. This is kind of painful, so I choose something smaller, and I made those end stop. This is more to avoid if there's any problem your cart to go outside the railing. And yeah, so they are, I think it's 18 millimeters both. I'm going to install that, and just need to put the screw. I think they are M3 screw, so at least the railing will be done while I'm still waiting for the screen and the Wi-Fi part. It's been a few days already, and I've continued to receive pieces here and there. I finally received my Wi-Fi module from Big3Tech. Since I'm still working on the bed, this is the plate for, I think it's a Creality CR10 Max or CR5, I don't know, there's too much model on Creality, and I've printed a template with the hole for the bed from Anycubic, and this is supposed to be like that. And already point here the hole I have to make, and the red line is the railing where it's supposed to be. So the goal is to drill the 4 corners to place the bed, so I could put the plate on the top of that, and then I could use the previous holding the previous plate and mark the hole here and be sure everything is working well. This one will allow me to change the bed if I ever need to change. I'm not bound to Anycubic anymore. I can use Creality heatbed as long as they are still in 24 volt. I should be fine. I've also received the part to wire the screen. So I have my ribbon cable. I was out of ribbon cable. I have my parallel port. So I also bought this This is belt tension. This is for the X-axis and should be compatible with the Chiron. And I've also 3D printed those parts. I will also put the link in the description to the Thingiverse source. This is for align properly the belt, because right now if you have the print head, the belt is not really flat, it's somehow in triangular shape to hold the moving part, and this should help to put it really flat. Again, I will put everything on the description, all the part I use. And yeah, so let's drill this plate and try to fix it to the railing system. So after taking some measurements, this is where my two carts should be. They are really close to each other. The reason is since I'm using only 550 rail, I'm losing a bit of space, and if you are using 600 millimeter rail, it will give you more space between the two carts. So yeah, they are really close to each other. This should match. As you can see, this is basically the same size as the pulley, so it should be okay. But yeah, I would have preferred to have more space and have better stability, but this is what I'm going to deal with. So yeah, just put the 16 hole so I can fix the cart, and with the belt fixation I have also 3D print a spacer, so I will have my belt really flat and not getting pulled toward the plate. So yeah, first let's drill our 16 hole. I placed the Wi-Fi module, an XLR antenna here, so I can eventually remove it if I have too much interference, and I would put a real antenna like a Wi-Fi one. I've swapped the color here for the connector, like that I am compatible. It's the same plug as the Ender 5 Plus, if I'm not mistaken. And I've also pimped it up a bit, the gauge of the wire here. So I think I finished all the electronic here. I've also worked on the cable for the screen. So I cannot print right now the enclosure, but at least I will be able to plug the screen. And I've also made the cable with parallel, so like that I will be able to plug the cable here. As you can see, it's 45 degree. Maybe I would have preferred to both a 90 degree, but like that. So there I can plug the screen without any problem, and then I could either go on the top, or what I'm planning to do is to put just right there, so it's not going to interfere with the exhaust of the driver for the stepper motor. And here, this is a classic plug, and I will be able to plug to whatever I need. So now that the panel is closed, I will just finish here. So add a belt tensor here, and on the bottom of the moving part here on the head, this is going to be under that, and push like that, and push the cable which is outside the 2020 extrude aluminum, and should have a better way to tense the belt.
This is the love making.
So while I'm printing again the part for the head for the x-axis and the new belt, because of the new belt tensor it's too short, we are going to try to work on the heat bed. The thing is, I was planning to add those silicone feet. The problem is the bed is really too thin. As you can see here, it's really too thin, so I'm not sure I'm going to be able to even make a countersink hole and drill on the other side. So I have multiple solutions here. One is to buy a new bed entirely. I need to see for the under 5 plus, I think, because it depends if it has the frame around there, get a metallic frame. The other solution is I bought some double-sided Kapton tape. What I could do is bought some 2020 extrude aluminum and make a frame to have something more rigid on this side. I really want to this thin aluminum plate not bending, not bowing. So the original heat bed is using a glass plate with special surface Anycubic leather ultra basis, but yeah, it's not really sticky anymore. So at least what I'm going to do, what I'm waiting for the part, and then deciding what I'm going to do with the fixation. I'm going to change here the cable. I'm going with 12 gauge. I think those one are 14 if I remember correctly, and it's a bit under what this bed is supposed to draw, so I think it's 11 or 12 amp. So we're going to beefy this cable. I'm going to change the connection. So this is going to be the jack for the sense and this one. I'm going to use this XT60. If possible, I want to put this strange relief, because since you have a lot of back and forth, you're putting a lot of unnecessary work on the cable, so I want to at least protect that. So yeah, let's do this. Let's talk a bit about the heating bed. Not everything is going to according to my plan. I was supposed to use those silicone rubber feet, but the countersunk hole is not big enough for the fixation. Because of the washer, you cannot put them. I've 3D printed those ones. They're on PETG and they are going to work fine. I need just to remove the skirt around them, but this is going to be just fine. They are the same height, I think it's 18 millimeters. For the fixation, I was planning to drill some hole and put them. The problem is the bed is too thin. Even if I put some countersunk screw, this is not going to work. So what I'm going to try is put other feet or large part on the same height, so 18 millimeters, and I will just try to stick them with the double-sided tape. The goal is at least not bowing down. I'm not sure because by the way the heating is working, it's making the bed like a piezo, you know. So sometimes it's warping up or warping down depending on how the heat is going through the bed. So I will try something, not drilling anything, see how it's going to work. If it's not working, I'm going to drill. I really don't like that, but this is the only way I know, because the flatness of this bed is not done by the heating element, but by the glass on the top of it. And since I don't have any glass anymore, since I removed the ultra bases, I will have to find something thick, another glass without any surface or anything on the top to make it flat. And again, if you don't stick, the middle can bow on the down while the top glass is still trying to be flat, so you will have a gap, you will have a loss and uneven surface to heat. So I'm at least going to try that, either print other surface and I'm going to stick them, and try to stick them also on the moving plates. So another thing, I removed the chain because it was really too big on the back, really too long, and I think it puts way too much stress on the structure than just having the stress relief here with zip ties and guiding the cable on the outside. So yeah, I'm going to do that, and we'll see where it's going. The first thing to do is to download the depository of the SKR 2 from Big Tech Trick from GitHub. We only need just one folder, but this is the way you have to do it. Just click on download zip, and this is going to open it up right after you download it. And we only need the firmware from RepRap Firmware. So go ahead and after you format on your FT32 your SD card, just drag drop from the zip inside. So this is just the base we need to start the board. It is really the minimum, but you need to configure it, so you can do either after that line by line into the config.g, or you can do it with the configurator from Teamgloomy here. So you may have different revision of the board. Mine is a SKR2 Rev B, so it's a STM32F4. Check on the board what difference you may have, and we're going to use the configurator. So we're going to use the custom configuration. This is the SKR2. We're going to use the latest firmware, and you name the printer here. We're going also to activate this when you're going to do the PID tuning. This is going to be like an EEPROM on Marlin, so I'm going to update the configuration. The size of our printer, we're on the Chiron on 40 cm square box. We're going to let the homing preferences. We need to at least start a bit to configure our drive. You can totally do that after that, but we need the E1. We're going to after that link the Z and the E1 for the Z axis and configure our gantry. We need the fan here. Fan 0 is going to be the cooling part. Fan 1 is going to be for the stepper motor driver, and fan 2 is going to be to cool our heating element. We're going to use the probe for the input, and if you're using a BL Touch, use servo 0. So I'm going to publish the file with the ability to put the BL Touch. Next, so as a stepper driver I have 2209, same for the extruder. I'm just going to edit the extruder 1 as the same as the Z. All my cabling is done for using forward motion, but if you have a different wiring, you can change that after on the configuration file. We're also going to change the current. So I had issue with only 800 milliamps, so at least I recommend to use 1000. If I remember correctly, I found on the internet that the stepper motor used on the Chiron are 1050, but you start to have warning if you put more than 1000. So just start with 1000, and if you have like issue with your motor making grinding noise or locking while printing, you may have to increase the current on the configuration. Then we're going to configure our switches. So we're going to let like that. For the Chiron, we're going to have to make some modification on the configuration. We're going to let them at the low end, so 0, 0, 0 for each axis. For the probe, we're going to let like that, and for the trigger height, depending on the revision of the probe you're using, if you're using the default from Anycubic, it's either 15 something or 13 something. Again, you can change that later, so I'm just going to use 15. I think mine is 15768, so you will have to look at the documentation how to set up the proper height, but this is going to be closed if you're using a default prop. Then we're going to let PID, and all the defaults are working with the default heater and heat bed. If you have already changed the heating element on the nozzle, maybe you can check where you maybe you can check if you need to change that, but we're going to use a PID tuning later. For the fan, we let the part cooling and the fan 1, we're going to handle them in the G code, and for the fan 2 we're going to link it to the heating element 1, which is our nozzle, and you can let for 45 degrees, but 70 is fine too. It's going to start at 70, and we're going also at full speed at 70 degrees. Then for the tool, we select the first one. It doesn't really matter because we can have only one tool on the Chiron. We're using the extruder 0, the heater 1, fan 0 for part cooling. For the bed compensation, this is where you're going to put the size of the grid for probing. You can do something like that, and 20 millimeter spacing for each point. If it's too big, you can just put a bigger number, and it's going to probe less point. So before configuring the network, we're going to go back, and I'm going to add the Big3Tech TFT monitor. So as you can see, if you have the printer is not connected, you will need to change the S2 value by S3. It's depending, I had some issues, so sometimes I have to ping pong to make them, but right now S2 is working currently on my Chiron. Next, this is where we're going to put our parameter for the Wi-Fi network. So just put the SSID of your network and the password. The thing is, the Wi-Fi is not working on my house currently. I'm using an Asus router with both Wi-Fi on the same SSID, and the ESP 8266 doesn't like that. So I will show you how to put the printer on an access point, so it will work with you have to connect to the printer and not the printer connect to your network. And finally, you can check all, or you can let the checkbox, and it will download the latest DuetWeb web control, RepRap, and ESP. So just click on finish. So you can just download the zip file. So you will have something like that, a sys file in a zip, a sys folder in a zip file with all the configuration we have done, and just download the rest. So once it's done, you have to go in your USB drive, and the WW, you just drag drop everything from the DuetWeb controller SD, and everything should be fine. Then you go into the main folder, and if you go into your download, you will have the new firmware. Drag drop it. You can delete the old one and put the new one on firmware.bin. And for updating the Wi-Fi, what you can do is to create a folder named firmware, and put the DuetWeb server file, and just rename it DuetWiFi server.bin. The thing is, you will also have one into the sys folder, but I'm going to show you a method where you can just put the SD card and it's going to update. So one other thing I'm going to give you is a zip file with already everything you need, and one of the files which is very important is the run-once.g. So the run-once.g is a script which is launching the first time you power the board, and it will self-destruct after running this code. So it's already commented. This is to connect to a router, and this is what you have to type to put it into an access point. So I'm going to let it for an access point. You can change here password. So the SSID will be Chiron, so I'm going to appear at a Chiron network on the Wi-Fi, and then I'm going to connect it. To update the firmware of the Wi-Fi module, this is what I'm going to use. So first I'm going to disable the network. I'm going to run the update which on the file which is on the firmware folder, and then going to wait 1 minute to let the firmware do its job. You may have an error saying the SSID is incorrect, but this is where the rest of the script is going to continue, which is going to disable the network, wait 5 seconds, update the Wi-Fi access points or the Wi-Fi connection, wait 5 seconds, and then restart the network. So also I'm going to put directly all my parameters, so the config.g with everything, and once I'm going to connect to the on the DuetWeb server, I'm going to explain what I've did. After you connect to the Wi-Fi, this is what I have since I put it into an access point, and then when you log with the IP, you've got this interface. First of all, what I like to do is to go to General and put it into a dark theme. You've got some plugin you can start and stop. I've stopped the accelerometer because I don't have one, and I've stopped the on-screen keyboard because it keeps popping up and I really hate that. I will let you discover how this is working. First, I need to show you the config.g and all the modification I've already done, and you will already have. If you want, you can compare with the zip file you got directly from the Teamgloomy configurator to see what I've done. So to go quickly, the first thing I've done is set up the extruder. So when you start, you will have the E4 there to set up the other extruder, but we are going to use the fourth motor as a Z. Already explained the two Z motors connected to driver output Z and E1. So there. Then this is the position of the two lead screw for our Z gantry. Here is the micro stepping per millimeter. As I say, this is the value I had, but it will depend on of your belt tension. It will depend on a lot of things. So go check Teaching Tech's video and his website about how to configure that. Here, this is the value I have currently on my printer. You will have something different. Same for the axis limit. My origin is outside of the bed print, so you may have to adjust there for your need. So this, for the end stop, if you haven't changed anything on the wiring, this is how you put it on the X and the Y stop. For the Z stop, you don't have to touch it, but you have to add the E1 stop. So you will have the end stop for both Z axis lead screw. So for the filament, I add this line. This will monitor the filament if you have put it in the E0 extruder end stop. For the Z probe, right now it's in comments, but this will be set if you're still using the default probe by Anycubic. And this is what a BL Touch is looking like. Mine is at this position. So again, it may vary depending on how you put it, and you will have to put the offset and the trigger and all this stuff. But it will be commented on the zip file you will have. Same thing for the thermistor. Mine is like that, but you will have some difference if you are using the default one. It will be for the row 92, you won't have this line. But yeah, I've already changed the thermistor. The fan, as you can see, we have our fan 2 at a temperature of 70 degrees, which will be running at 100%. So the value, you can check the documentation, but 1.0 is in fact 100%. So one thing also is by default you will have the bed.g, which will be somehow different, but it is already configured to check the lead screw and the deviation of the lead screw. Again, this is the value I have, so you may have to change that. This will be launched for a G32 bed calibration. You will also have the Ohm X, the Ohm Y and the Ohm Z. So I haven't touched the Ohm X, which will be like that. It's probing 2 times. And the Ohm all, like it's supposed to be all this code, but I've already replaced with just calling the file, so you won't have to copy paste every time. Just edit Ohm X, Ohm Y and Ohm Z, and will automatically be called by the Ohm all. So this is the explanation of the file. You can check the documentation if you want to add and tweak it on your style. So once it's done, try to ohm each axis, and if it's don't do what you want, just press the emergency stop and change again the config.g. If you have trouble to configure and to access to your web interface, I strongly recommend to go check the video of Chris Riley about how to set up manually the Wi-Fi and on the SKR2, and you will have to plug it into a PC and use a terminal to put all the value manually. Once you have everything working and moving correctly, you can try to do a PID tuning. So you can check again Chris Riley or Teaching Tech, which have both excellent tutorial on how to set up. But if you haven't touched anything and you are still using the default parameter, you should be okay. So the only thing you will have to do after that is do a true bed leveling, which is the bed.g. I've already shown you. Remember to put the bed heat because you don't want to probe with the cold bed. Bring it to the temperature of the filament you're going to print. And when it's done, you will have to do the run mesh compensation. This is going to probe the grid we have defined, and it will save the other probing into an height map. This is currently my bed. And after that you should be ready to print. Again, you can check Chris Riley channel or Teaching Tech channel. They made already a lot of tutorial about the SKR2 and RepRap Firmware, so they should be helpful to find information. And also you can check the documentation online if you have to tailor on the specification of your own printer. I've been working on the leveling. As you can see, this is the original Ultra base, and yeah, because I've tried to level as best as I could, and unfortunately the bed is warping, like heavily warping. My stands on the bottom do absolutely nothing. They were like popping and not sticking on the aluminum bottom. It was sticking on the heatbed though, but was just not holding it. It's a kind of bummer, because after that I just throw the Ultra bases on the top and see what I could do, and just send another bed leveling, and it was much better. Not perfect, much better. My understanding is like the screw, which are the 4 screw here, which are holding the bed, are not really, I didn't screw them really plumb, so they are slightly bent, and so it's making the bed warping on the corner. So even if on the center I have a lot of stands, it's somehow making the whole thing flat. It's not really perfect. So the bed is really too thin to do anything. So I guess I'm stuck to either put back the Ultra base. I'm not sure how the micro porous surface is going to behave if I remove the magnetic support here to put back the bed, and then on top of that I will need to put the magnetic again. I'm not even sure if this is going to transfer the heat correctly, and this is supposed to contract when it's heated and dilate when it's cooled down. So I'm not sure how adhesive are going to work on that. So I could just buy another glass bed. There's a smaller than the one than those one. I found them online. I could try to go into an hardware store and find some tempered glass. I found one online. I'm not sure if it's worth it, but because you have to pay the shipping, this is glass, it's very fragile. So maybe I will just remove the magnetic. I have another magnetic support because I bought another bed, another steel, a spring steel sheet, and it was basically the same price to buy another magnetic. So I say, why not? I need to remove that. Put back a glass on top of that. Not sure what I'm going to do because this is the glass which is really making the bed flat. Yeah, I think I'm going to buy another one. So I've just removed the magnetic surface and I'm currently trying to remove the glue. So of course you can try to use your thumb and spend half an hour just for a small part, but you can also try to use isopropyl alcohol, but it's not going to be very efficient. Best way to use acetone. Acetone is really efficient on glue. Everything which is glue related, you just pour a little bit of acetone. You have to be really fast. You will understand why. And now the acetone is going to work and make some goo from the glue. You will see how I try to move a bit. You can see how easily I can now remove. See? So you have to really be quick because the acetone is really volatile. It's going to really quickly dry, evaporate more likely, and it's making a really bad gooey mesh. You will see if you just continue, it will automatically dry and your spatula is going to be very sticky with a lot of residue. But as you can see, I just remove nearly half of the glue. When you have finished everything, you clean everything with isopropyl alcohol to remove the excess of acetone. But yeah, every time I have a large residue of glue to remove, acetone is really the best. It's really efficient. Not the best, but it should be fine. Now I'm going to put the bed on top of this. Can see the bubble on the bottom, so yeah, I hope this is not going to create pocket of heat. Seems pretty flat, and I think I'm just going to put it on the heat bed, because now I have to put another layer of double-sided tape. It's the same, you can see 3M 468 MP, and then I will put back the magnetic bed. So it was a really long project, but really instructive. I learned a lot on this project, especially on tweaking. So I'm going to try to finish up everything, because this was already way too long. I really thank you if you are watching this end of this second part. I've installed the tube here for the structure rigidity. It was for the creality again, so I have to print those corners to install. I've installed the screen. As you can see, it's on boom arm. This is really cool because I can stay straight and I can move the screen as much as I want. It's not perfect, there's a lot of stuff I will have to change. First, don't skip on the calibration of your E-step, because as you can see, this was my first test and the Z was completely squished on the Y axis. So after a bit of calibration, So go check the calibration websites from Teaching Text. This is really important. I'm still currently in the middle of calibrating my retraction. As you can see, this is all the tests you can done. So don't use fan 0 for the heatsink. This is going to be complicated because most of the slicer are using fan 0 for the part and not for the heatsink. So use fan 0 for the part cooling and fan 2 for the heatsink. I think I've already said that on the video, but don't do what I done. Fan 0 for the part, fan 2 for the heatsink. Do whatever you want with fan 1. I'm using to cool down stepper motor driver. Other issue, I still have some issue with the screen. It's like I've got G-code with not matching between what the screen is sending, probably inside the firmware, and the G-code I'm using when I'm on the web interface. Installation of the screen and the Wi-Fi, and if you want to plug it in USB with the proton face. It's kind of chaotic, I would say, because they are overlapping each other, so sometimes one is not working, the other is working. The ohming is working here, but there's a lot of stuff like the fan speed or changing the filament. It's wonky, so I still have to work on that, but it's on my side. I haven't checked really, but I still have to check that. The SD card on the screen supposedly is to be SD1. The card on the motherboard is SD0. So even if I try to mount one or the other, this one is not working. So I don't know why. So maybe it's my cable, but I'm pretty sure this is more of a I/O related. The bed. So it's really much better with the glass bed, but it's still bowing. I have some here around those. Not on the corner, but near the corner, I have 0.4 millimeters of a dip. So I don't know how I'm going to do. Speaking of that, the bed calibration. Right now, if I make a calibration with the probe, I would have to make at least the center bed before each printing, or else I'm going to have a warning saying like the declaration of Z0 datum is not probe. So I'm not even sure if my probing of the bed warping is really loaded. It's loaded on the web interface, but I don't know if it's really working. So maybe I'm going to have to upgrade the printing, all the printing elements. I still have the speed and all the fine tuning to do. Right now it's the default one, so really similar from what I have with Marlin 1. I don't know what version was the original one, but the thing is, I think the print is a bit better quality. This is the Benchy I've made with the default parameter. It's really good. I still have, as you can see, retraction issue, so that's why I was trying to do, but I made some printing of Mad Cat's bezel. So this one was wrong on the dimension, but this one has some bed layer adhesion because of the warping of the bed, but I'm getting there. It's better from what it was. I already saw an improvement of the quality, especially everything on the center. What I'm going to do next, eventually, is changing the hot end. I'm thinking of a Fetus Dragon. The reason is with the printer of this size, I would like to have a high flow and maybe changing for 0.6 or not in 0.4 currently, or have the ability to change to have for a very bigger print and not weight. This is going to be with the speed, because if I have an higher flow of a printing, I could print on a higher speed. Maybe change for a BL touch, so I could do my Z datum before each print. And maybe moving the extruder to put it on a direct. Right now it's in the with the bowden, but maybe you have a direct extrude. But for the time, I think I'm going to be like that. I already put way too much time, but I consider the printer saved. I hope I didn't miss anything. I'm sorry if this video is too long. I've tried to explain a lot of the process and the trouble I have. So go check the YouTube channel of Teaching Text. It was really my go-to for calibration and check if everything worked. I'm going to put everything I use as best as I could. Thank you again if you watch the whole video. I really hope you find some information you could use. So yeah, that's pretty much it. So thanks for watching, and see you soon.